See, now we are discussing about p block elements. In p block elements, chemical properties we are seeing. In that chemical properties, so now you are going to discuss about oxyhalides. So that is a combination of oxygen and halogen. Suppose you go to 15th group. So 15th group phosphorus is there. Phosphorus is what? Plus 3 plus 5 is there. Suppose you take phosphorus plus 3, oxygen minus 2, chlorine minus 1. So it is plus 3 and minus 3 balanced. So you are getting a POCl compound. Next, P plus 5, oxygen minus 2. So remaining 3 charges are there. So you are getting POCl3. Next, phosphorus plus 5, you take 2 oxygens and Cl minus 1. So you can take a PO2Cl. See, in these three, only the POCl3 is famous and that is existed. So PO2Cl is not possible. So phosphorus forming one double bond O only. Two double bonds are not existed. If size is decreases, you go to sulfur. So that two oxygens with double bond is happened. So POCl3 is famous here. Suppose you go to 16th group. In 16th group, sulfur you take plus 2, S plus 4 plus 6 are there. See, if you consider plus 4, 1 oxygen minus 2. So 2 chlorines. So you are getting SOCl2 is possible. Next, S plus 6, O minus 2, O minus 2, Cl minus 1, Cl minus 1. 6 positives, 6 negatives. You are getting SO2, Cl2. So these two are famous compounds. The SOCl2 thionyl chloride, SO2 Cl2 sulfuryl chloride. Next, in 17th group. In 17th, see 17th only it is a halides. So that's why you called as simply oxides only. So no need to think about that one. Next, you go to 18th group. 18th group, xenon is xenon only forming compounds with one is fluorine, another one is oxygen. So that's why it forms oxyfluorides. So that is XeOF2, XeO2F2, XeOF4, these three. Now we will see the structures and hybridization bond angles. See, POCl3. So phosphorus 1, 2, 3, 4, 5. Fifth group you take 5. 1 oxygen, 3 chlorines. So total 4 sigma bonds. 4 sigma bonds, 0 lone pairs. So the number is 4. 4 means sp3. So phosphorus you take central, write down 4 bonds, double bond O, Cl, Cl, Cl. The structure is tetrahedral. Bond angle is nearer to 109 degrees 28 minutes. So this is 3 electrons is ground state. Next, this is excited state molecule. Next, SOCl2 you called as thionyl chloride. So sulfur you take 1, 2, 3, 4, 5, 6, sixth group, 1 oxygen, 2 chlorines. 1 sigma, second sigma, third sigma. So 3 sigma bonds, 1 lone pair. 3 plus 1, 4. 4 means what? sp3. But one lone pair is there. Sulfur, you take 1, 2, 3, 4 by seeing 4 number. 1 is a lone pair. You write down lone pair. 1 is double bond O, Cl and Cl. So the structure is a pyramid. So bond angle is nearer to 107 degrees. So 2 electrons is ground state. Next pair of electron means this is the first excited state molecule. Next, SO2Cl2. This is sulfuryl chloride. So sulfur 1, 2, 3, 4, 5, 6. So 1 O, second O, Cl, Cl. So 4 sigma bonds, 0 lone pairs. So that is a 4. 4 means sp3. So 0 lone pairs, that is tetrahedral. Bond angle is nearer to 107 degrees or 28 minutes. Next, xenon oxyfluorides. If you see that XF2. So xenon 1, 2, 3, 4, 5, 6, 7, 8. So 1 oxygen, 2 fluorines. So 1, 2, 3. 3 sigma bonds, 2 lone pairs. So 3 plus 2, 5. 5 means sp3d. So xenon you take central, write down 5 bonds. In that 3 are sigma. So that is what a T shape. Bond angles 90 degrees, straight line 180 degrees. So xenon oxide difluoride is over. Now xenon oxide tetrafluoride. So xenon 1, 2, 3, 4, 5, 6, 7, 8. 1 O, 1 fluorine, second fluorine, third fluorine, fourth fluorine. So 4 plus 1, 5 sigma bonds, 1 lone pair. 5 plus 1, 6. 6 means sp3d2. So xenon you take central, write down 6 bonds. In that 1 is a lone pair, 1 is a double bond O. So the structure is a square pyramid. Bond angle is 90 degrees. Next, XeO2F2. So xenon 1, 2, 3, 4, 5, 6, 7, 8. 1 O, second O, fluorine and fluorine. So 4 sigma bonds, 1 lone pair. So 4 plus 1, 5. 5 means sp3d. So xenon you take central, write down 5 bonds. In that 1 is a lone pair. So you can write as the structure is seesaw. So bond angles are 90, less than 120 and 180. So now we will discuss about oxoacids. So oxoacids or oxyacids. Suppose you take 15th group. In 15th group, nitrogen, phosphorus. These two are important. So you write nitrogen oxoacids. So that is HNO, HNO2, HNO3, HNO4. So first two you put star. See, star means us, lowest oxidation state. Without star means ik, highest oxidation state you remember. So first one, nitrous acid, nitric acid, below one, peroxynitric acid. So first we are concentrating on the structures, means names of the oxoacids. After that we will discuss about the structures and hybridization, all those things. Next, phosphorus oxoacids. So here you can write H3PO2, you can write H3PO3, H3PO4, H3PO5. So 2 to 5 you come down. Next, here 1 you increase. H4P2, O5 as it is you write. Next, H4P2, O6, H4P2, O7. Next here 3 number you remove. So HPO2, HPO3. So here 2 you write down, here star. So star means us. Without star means ik. So first one hypophosphorus. This is orthophosphoric. This is H3PO5 peroxyphosphoric. H3PO2 hypophosphorus, orthophosphorus. Next H3PO4 orthophosphoric, peroxyphosphoric. So now this is metaphosphoric acid. So this is hypopyro. So H4P2O5, this is a pyrophosphorus acid. H4P2O6, hypophosphoric acid. Next H4P2O7, pyrophosphoric acid. Always you remember, star means us, without star means ik. This. Next, in 16th group. So in 16th group we have sulfur oxoacids. So here H2SO3, H2SO4, H2SO5. Next here, one oxygen you decrease, one sulfur you increase, H2S2O2. One oxygen you decrease, one sulfur is increased. Next H2S2O3, H2S2O4, H2S2O5, H2S2O6, H2S2O7, H2S2O8. These. Next, this is us. Here you put one star. Next you give gap. Next two continuous us you give. So this is sulfurous, H2SO3, sulfurous acid, H2SO4, sulfuric acid. This is peroxy, monosulfuric acid. So famous name is Konnur's acid. Next below one is peroxy, disulfuric acid. The famous name is Marshall's. So H2SO5 is Konnur's acid, H2S2O8 you called as Marshall's acid. So first two, this side you write down thio. This is next one dithio, pyro. Next two, repeat you this one, dithio, next pyro. So H2S2O2 you called as thiosulfurous acid, H2S2O3 thiosulfuric acid, H2S2O4 dithiosulfurous, H2S2O5 pyrosulfurous, H2S2O6 dithiosulfuric, H2S2O7 pyrosulfuric, otherwise oleum. Otherwise, fuming sulfuric acid. The oleum or pyrosulfuric acid also called as fuming sulfuric acid. Next. Seventeenth group. So 17th group in this we discussed about chlorine oxoacids. So chlorine oxoacids are similar to nitrogen only. So HClO, HClO2, HClO3, HClO4, similar to nitrogen. First two are us. So hypochlorous, so that is hypochlorous acid. Next chlorous acid. Next HClO3, chloric acid. Next HClO4, perchloric acid. So HNO4 means peroxynitric acid, but here perchloric acid. So in our organic chemistry, HiO4 is famous. What is this? Periodic acid. This. See, next, how the oxoacids are coming. Already we seen, once again I am explaining, non-metal oxide, non-metal oxides added with water. So you are getting oxoacids. See, this non-metal oxide you called as anhydride, anhydride of oxoacids we called as. See, suppose nitrogen N2O3 plus water, N2O4 plus water, N2O5 plus water. See, next P2O3 phosphorus plus water, P2O5 plus water. These are what non-metal. So here 2 moles of HNO2. Here HNO2 plus HNO3. Next here 2 moles of HNO4, HNO3 nitric acid. So here H3PO3, here H3PO4. So phosphorus acid, phosphoric acid you are getting. Next sulfur, SO2 plus water. You are getting H2SO3, sulfurous acid. SO3 plus water. You are getting H2SO4, sulfuric acid. Next Cl2O plus water, HClO. Cl2O3 plus water, HClO2. Cl2O4 plus water, 5, HClO3. Cl2O7 plus water, HClO4. So like that.